right, guys, here we go. Review for test 9. Number 1 says find the radian measure of 36 degrees. The shortcut for doing radian measure when they give you degrees is just take the degree, the 36 degrees, divide it by 180, and put a pi with it. Okay, so I'm gonna reduce that fraction. 36 goes into 180 5 times, so I'm just gonna get 1 pi over 5, and that's the radian measure. Going backwards here to find the degree measure, the shortcut for that, or 5 pi over 3 radians, is remember pi radians is really 180 degrees, so I'm just gonna put the 180 degrees where the pi was, and work that out. And if I punch that in, 5 times 180 divided by 3, I'm looking at 300 degrees. Number 3, find the measure of one positive and one negative angle as coterminal. Remember, coterminal is the same spot on the unit circle except a different measure. So the way you find it for degrees is you add 360 and subtract 360. So if you take 120 and add 360, you're going to have 480. If you subtract 360 from 120, you're going to get negative 240. Remember, one of your answers must be positive, one negative. Now this one is in radians. So with radians, instead of 360, think about radians. You're going to add 2 pi. All right, so 2 pi, look at the denominator. The denominator is 3. If you double that, if you double 3, it'd be 6 over 3. So it'd be like 6 pi over 3 is the same thing as 2 pi. So if you add that, you get 4 pi over 3. That's the positive answer. And if I take the negative 2 pi over 3 and subtract 6 pi over 3, you get negative 8 pi over 3. So those are your two answers there. And then number 4, find the length of an arc that subtends a central angle of 45 degrees, the radius of 12. Now here's our formula we use for that. We go theta is S over R. Remember, S is the arc length and R is radius. That formula only works in radians. So what I'm going to do first is take that 45 degree angle, and just like in number 1, I'm going to change the 45 to radians by dividing it by 180 and putting a pi with it. That's going to be pi over 4. So the theta is pi over 4. That's the angle. I'm looking for the arc length. It says find the length of the arc. That's S. The radius is 12. When again, I'm just going to cross multiply. 12 pi is 4S. Divide by 4. I would get 3 pi. You can take your calculator and punch in 3 times pi if you want to. Matter of fact, that'd probably be better since it says length of the arc. I don't have my calculator here with me, so I'm just going to put 3 pi, but probably get a decimal there. Number 5, find the exact values of the 6 trig ratios. Okay, so remember, I always go this way. I go sine, cosine, tangent, and then out beside those, I'm going to the reciprocals, which are cosecant and secant and cotangent. Now, this is not one of my famous ones. I don't think. It's not. It's 7. Hypotenuse is 8, so I need to find that third side. So I'm going to go basically a squared plus b squared. 7 squared is 49 equals c squared. A squared is 64. Move the 49 over, I get 15. That's a squared, which means this side over here is the square root of 15. And here I go. Here's my theta. So the sine is opposite over hypotenuse, which would be 7/8, which means that's 8/7. Cosine adjacent over hypotenuse, which is square root of 15 over 8, which means this is 8 over square root of 15. Remember the shortcut. Move the radical to the top, take the number on the bottom. The tangent is really sine over cosine, or opposite over adjacent, which should be 7 over the square root of 15, which ends up being 7 on 15 over 15. And then cotangent is reciprocal of tangent. Remember, I'm going to flip this one, not the other one, because the other one's much too difficult to flip. Okay, number 6 and 7 are both solve the triangle. All right, so you're going to need your calculator here. You got to find everything that's missing. So the first thing I noticed in number 6 is that this angle must be 38 degrees because all 3 angles together must add up to be 180. And now I'm going to do trick. And again, guys, there's so many ways you can do this. So many. I'm going to go here first to find this side right there, opposite the 52. I'm going to go tangent of 52 is opposite over adjacent, which is x over 35. I'm going to take my calculator and punch that in real quick. When I do that, I get 44.8. So that side right there is 44.8. Now I got to find the hypotenuse. So I'm going to use the same angle right there, and I'm going to say cosine 52 is adjacent over the hypotenuse, which I don't know, so I'm going to put a little h down there for hypotenuse. So I'm going to remember to do this because the h is on the bottom. I'm going to do 35 divided by cosine 52. When I punch that in, I'm getting 56.8. So there's that one. Okay, number 7, same deal except for radians now. Okay, this has been a fun one for us this week. remember, the right angle is always pi over 2 because 90 degrees is half. Remember, 180 is pi, so 90 is half of 180, so half of pi is pi over 2. Find the LCD, which is 8. Up there I have 3 pi over 8. Since this is half, half is really 4 pi over 8. 4/8 is a half. All the angles inside the triangle have to be 1, which is 8/8. So 4 and 3 is 7. I need one more 8 right here, so I'm going pi over 8. That's the first answer. Now I need to find the two sides. So I'm going to go, and again, there's so many ways you can go here. I'm going to go sine of 3 pi over 8 equals that side over hypotenuse, the opposite side, x, which is right here. I'm looking at that side right there, that x. So I'm going to punch that in real quick. And when I do that, I get 392.6 when I get that side. Then I'm going to use the same angle, except I'm going to go cosine 3 pi over 8 because I'm looking for adjacent now. So I'm going to do the adjacent side, make that be x this time, over hypotenuse 425. So I'm going to punch that in real quick. And I'm getting 162.6 on that one. Hope that's good. Let's keep on going. Number 8, sketch a triangle that has this acute angle and find the other 5 trig ratios. So this one you got to draw your own triangle. The first one's really nice because it's one that we know. I'm going to put that, you put that wherever you go. I'm going down there. Sine is opposite over hypotenuse. So I'm going opposite hypotenuse. And when I see 8 and 17 is the hypotenuse, I know it's going to be an 8, 15, 17. So that's sine. Cosecant is always reciprocal of sine. That's 17 over 8. Cosine is next. Cosine is adjacent over hypotenuse, 15 17ths. Secant, reciprocal of cosine. That's going to be 17 15ths. Tangent, opposite over adjacent. And cotangent, reciprocal of that, which is 15 over 8. All there is to it. Number 9, cotangent. Now here's the deal about cotangent. If cotangent is square root of 3, that means tangent is 1 over the square root of 3. And that's important, but I'm going to go ahead and change that to, square root of 3 over 3. I'm going to draw my triangle using tangent. So there's theta down here. Remember, tangent's opposite over adjacent. So opposite is 1, adjacent square root of 3. And I got that from that first value. You know what that is, just looking at that? I'll do Pythagorean theorem if you want to. If you do Pythagorean theorem, you're going 1 squared plus square root of 3 squared equals c squared. That's going to be 4 equals c squared. So c is 2. That's a 30, 60, 90. That's a 1, 2 square root of 3, right? I knew that when I saw the 1 and the square root of 3. Hopefully you did too. Right? The sine of theta. Sine is opposite over hypotenuse, which means cosecant is reciprocal of that, which is 2. Cosine theta is adjacent over hypotenuse. And of course, secant is reciprocal of cosine. So you get 2 over the square root of 3. Take care of that radical for me. It'll be 2 on 3 over 3. Perfect. Number 10, find the inverse of this. And this was on there again because last week we struggled with this. Get it right so we won't put it on there every single week. Inverses. Switch the x and y. That's the first step. Then you got to get the y by itself. So what I'm going to do is I'm going to cross multiply. So I got xy plus 2x when I go this way. When I go the other way, 1 times y minus 2 is y minus 2. 2 steps here. You got to get the y's together. So I'm basically going to switch places with those two terms. I'm taking the y over here and the 2x to the other side. And then to get the 1y, you got to factor out a y. So I'm going to factor out a y over there like this. And then divide both sides by the x minus 1. Because it says y times x minus 1. The opposite times is divide. Do that right there. A good idea to erase the y, remember. And put the correct notation, which is inverse of f of x. And there it is. Number 11, find the inverse of this one. This is a little bit easier inverse. Again, switch the x and y, put the x over here. Let's go y over here. Then you take the cube root of both sides, get rid of that cube root. And then I'm going to add 4 to both sides. So you get the cube root of x plus 4. It would be nice if you change the y to f negative 1. All right, number 12, find the average rate of change. Been a while for this one. Rate of change, remember, is just slope. So I'm really going to do y2 minus y1 over x2 minus x1. And by the way, here's my x's. So my denominator, my x2 is going to be 3 minus h. My x1 is going to be 3. Let's go ahead and just finish the bottom. The 3's are going to cancel. I'm going to get a negative h down there. Now to get your y's, you must plug in 3 minus h, and then plug in 3. Now when I plug in 3 right here into that x, 3 squared is 9, 2 times 9 is 18, so we're going to get 18. So I'm going to do square, multiply double square. I got 2 square, multiply double square, minus 18. I'll watch what happens. If I distribute the 2, it's 18, minus 12h, and then plus 2h squared, minus 18, all over negative h. The 18's cancel. I get negative 12h plus 2h squared over negative h. I'm going to factor out, I'm going to divide a negative h into everything. So if I do negative h into that first term, I get positive 12. And if I do negative h into that term, I get negative 2h. And there it is. There's your average rate of change. 13 looks like the last one. That's awesome. Piecewise. With piecewise, I'm going to take the negative 4, plug it in there. If you plug in a negative 4, there's already a negative sign there. So if you do negative 4, that's positive 4. So I plugged in negative 4. I got positive 4. And I'm putting an empty circle there because there's no equal sign. And because it says less than, I'm going to go left. So I'm thinking, what's the next number to the left of negative 4? A negative 5. So if I plug in negative 5, it gives me positive 5. And because it's a line, I'm going to go ahead and connect the dots. La, la, la. Okay, this one, great. This is constant. There's no x at all. It's going to be a horizontal line starting at the negative 4. So I'm going to go negative 4, 1. Sorry, negative 4, negative 1, which is down here. And I'm just going to stop at the 2. If I go to 2, negative 1 is right here. That should be an empty circle. Almost messed that up. And then boom, it's right there. And the last one is also a line. Plug in the 2. If I plug in 2, it becomes negative 2 plus 4, which is positive 2, which is up here. And because I'm going to the right, the next number to the right of 2 is 3, so I'm going to plug in a 3, which means it becomes negative 3 plus 4, which is 1. There's no second point because it's a line. You can go ahead and connect the dots, la, la, la. And there you have it. There's your piecewise. Hope that helps you. Hope you do great tomorrow on the test. First test this quarter. See you then.